Hello, this is Mr. White.
And this is Mr. Haley.
This is a podcast that will show you how to model with trigonometric functions within Logger Pro. So, in order to start here, we need to take a video of a bike. We're going to do that by going Insert, Video Capture, and you see us. Hey, here we are.
Peace, man.
Cool. Okay, so what we're going to do first is we're going to line this up with a bike tire.
That looks pretty good.
We're going to do a start capture, and then we're going to spin this bike tire. You're going to notice that it doesn't look very good in this video, but we're going to, as soon as we stop and close, the video will actually be pretty nice. So first go page auto arrange, and you'll see the video, and we can scroll through it. Scroll through, and you can see the video is actually pretty good. So let's start a little bit after the start of the spin, so it's moving pretty fast. And I think starting at the top here is pretty good. Okay, so Mr. Haley, we are going to hit these three red buttons here, colorblind. Click this one, add a point, and we'll just take it right from the center of these, this orange reflector. Okay, does that make sense, Mr. Haley?
It looks fantastic, and in fact, it looks like the points are all going to make a lovely circle, which makes sense.
Okay.
And so what it's doing now, after we click, it's advancing the video one frame. And that makes this very, very useful. And we're going to go ahead and do 3 revolutions of this.
You know, this is Miss Koss's bike. It might be sort of oval shaped. She doesn't take very good care of it.
She's left it outside the math department in the environs for just under a year.
Just under a year.
So this poor bike has been
never been ridden.
Never been ridden.
This is the first time the wheels have been turned.
Yeah. And we're going to call Bike Protective Services and report her because she's mistreating her bike.
Okay, so
But
we're almost
it is
there.
nice that we had a bike to use today.
That is nice.
That is nice. Because I drove today. Did you drive?
I drove.
I drove. We could be doing this on our car, I guess. But that would be a little more dangerous.
Going away from the school.
Exactly. Waving goodbye.
Okay, so I think this is about enough, right?
That looks great.
We've got a bunch of points over here, red and blue points. We actually only want the blue ones. So click here, it says X
And what would the
Y.
red ones represent?
It's the distance from, well, it's actually assuming that the origin, whoops, that wasn't very good. The origin is over here, so it actually is representing the distance in the x-axis.
From the origin?
Yeah, and then the blue is what we want.
So we're going to have to change where our origin is. Let's go first get rid of the x.
First get rid of the x. So click on the xy here, push more, and then unclick the x.
There it is. Okay.
Just have the blue ones.
There they are. Now, already I'm beginning to see that they kind of follow a little pattern as expected.
What's the x-axis, Mr. Haley?
The x-axis, what is it?
Yeah,
This is going to be time in that direction,
in
yes.
seconds. Okay, so now let's do some other stuff here. The first thing, let's change the
center of our origin. Yeah.
And just click right there and we can move it around. I think this is a good center. If you guys want to be a little bit more creative and put it down here, feel free to do that. But we'll just keep it
But we'll make
simple.
fun of you, so.
Yeah, all right.
All right.
Next thing we want to do is click this ruler button, because this 100, the computer just makes this up, like 100 pixels or something, I don't know. So we're going to set scale. And we're going to go from the center here out to the end of the rim, and we know this rim is
42 centimeters.
42 centimeters.
Make sure to change the meters to centimeters.
Okay, and there we get. So it actually auto fits for us. Which is
Nice. God bless those people at Logger Pro.
Made in Portland, Oregon.
Made in Portland, Oregon, by people who care. Okay. All right, now we go click on this little curve fit button.
And we go down, and you see right here there's a sine function made for us, but you can see that it's bt plus c, and what we're used to is b parentheses t plus c. So we're going to actually define a new function. This will make it a little bit more complicated. We're going to make a new function, and it should be easier. So let's get
All right, you can
rid of that one.
there. A times sine.
We need times, right?
Yeah, put the times there, otherwise it somehow messes up. And we're going to do b times parenthesis T minus capital C, close, close, plus D, right?
I think you get rid of those spaces there.
Oh, really? Not really friendly with the spaces. People in Oregon don't like spaces, make a note of that. So, sine wave. All right, here we go.
Okay, so now we have our 4 constants that we need to pick.
All right, so let's take a look first here. What do we think this amplitude is here? Going from our principal axis, going up to the top 20, somebody, 28?
28.
Sounds good. All right, that's interesting.
D.
And D.
0.
0 looks good.
Okay. B, these are the hard ones.
Uh-oh. Okay, so let's start with the period. Let's not rotate anything first. But let's take a look here. Right here, we've got this one coming in at about 4.8, maybe, 4.7. And this one complete wave later, pretty much right there. It looks like it's 4.8 maybe. So maybe 1.1 is the length.
1.1.
So then we have to actually change that to the coefficient, which means we have to take 2 pi and divide by 1.1, did we say?
1.1.
All right, hey, that looks pretty good. And you'll notice the Logger Pro updates it as we do it, these changes. So now we just need to do a little horizontal shift. And it looks like we need to horizontal shift about, I don't know, 0.6. Oh my God, 0.5. Wow, we're good, Mr. White.
0.45, how about that?
Yeah, it's not bad at all.
That's pretty good. That's really good.
So, all right.
And if it doesn't fit too well, but you get we see that there's about 3 maxes that it's actually quite good, but this minimum, and that can just be resulted from the fact that the bike is speeding up from these from a few seconds here.
Sure.
So, yeah.
Maybe change the A to 27 just to see what that does. I know we're just kind of tinkering now. Ooh, I kind of like that better.
Yeah, I like mine.
You really? Well, mine's better.
Let's compromise.
There you go. Please.
Okay.
No, mine's still better. But
So
anyway,
there we
we'll
go.
leave it there.
So your assignment is to make 2 waves, 1 sine and 1 cosine, fitting
For the same data
bike.
points.
Same data points for this bike. Good luck.
And it would be nice that if you do this in a Word document, put a picture of your bike path, put a picture of this stuff over here, and then do another screen capture of these over here, including with this data right here showing.
Good.
Okay.
This is a homework assignment for each group.
Each group, yes, you do this in your group.
So one printout per group with your names at the top.
Gotta love that.
Love it.
All right,
Good luck.
thanks.
Bye-bye.